In this experiment, you'll learn how to trace the flow of current through an electrical circuit and how to use a breadboard. Start off by making a copy of the circuit from our second experiment using the fork link. And give it a new name. And go back to edit mode and start the simulation. And the circuit works as before. The reason the circuit works is that electrical current, the battery forces electrical current to flow from the positive terminal through the wire into the multimeter, using the positive terminal called the anode, then out of the negative terminal of the multimeter through this wire and into the positive terminal of the LED called the anode, through the LED, which makes it light up, and then out of the cathode, and then back on through the resistor and back into the battery, and then it goes back around again. So the current makes a continuous loop through the circuit, like so. Now we're going to stop the simulation and we're going to delete the multimeter and start the simulation again. Okay, as expected, the LED does not light up because there's no longer a continuous path for the current to flow through the circuit. So stop the simulation, reconnect the circuit, and start again. Now we're going to stop the simulation and we're going to replace this wire with what's called a push button. And then we'll connect it up like this. And start the simulation. And the LED does not light up. And the reason it doesn't is because this push button is normally open. So inside the push button, the circuit is actually open, and so no current flows through it. But when we click the push button, the circuit becomes closed and stays closed with this particular switch, or push button, which is a type of switch. This is basically the same as a light switch. It lets you open and close the circuit at will, manually. Now we'll stop the simulation, delete the push button, and add a breadboard to the circuit. Close the components panel and zoom to fit, and do a little repositioning. Next we'll connect everything to the breadboard like this. Connect the positive terminal to one of these holes here, and connect the positive terminal of the LED to one of these holes here, and start the simulation. And the LED once again lights up, even though it appears that the circuit is open. But what's actually happening is that there's a wire underneath this row of holes here, and that's providing the continuous path for the current to flow through. So the current can flow out of the positive terminal of the battery into the underlying wire here, and then back through the circuit as usual. And so that's the key to breadboards, is that there are wires underneath certain groups of holes that provides a connection for them. So this row, on this row, all the holes are connected by a wire. Then there's a separate wire connecting all of these holes. And same for these two rows. and the same for each of these columns of holes. Each of these columns are 5 holes. There's a separate wire underneath each of these columns, and the same for these. And that's the key to a breadboard. Okay, so after a bit of repositioning and zooming in, our circuit looks like this, with each of these components placed into the holes of the breadboard. And it doesn't really matter which holes you use. And now we want to complete the circuit, to close the circuit. So we want the current to flow from the positive terminal here, and now it's flowing into this row. And now from this row, we want it to flow into this column. You can see how it ends up connecting to the positive terminal of the, actually that's wrong, that's the negative terminal. So let's connect to the positive terminal. And then we're going to connect the negative terminal of the LED to the resistor. And then from the other end of the resistor, we'll connect to this row here. And so now we can see that. Let's run our simulation and see what happens. Okay, so the LED does light up. And the reason it does is because the current is flowing from the positive terminal of the battery into this row here, then from this wire into this column, into the positive terminal, the anode of the LED, out of the cathode, into this column, through this wire, and etc. Finally, we hit the negative row, and from there it can go through this wire back into the battery. So this is the key to breadboards. It makes it really easy to connect your circuits in the real world. In the virtual world, we don't really need it, but in the real world, this is a very easy way to create real circuits.